All right, Algebra 1, today we got your 1,4G notes, and basically what we're going to be doing today is raising a power to a power. So let's go back to our bell ringer and review what we were looking at yesterday. So if we have something like this in your bell ringer, and we're looking at our numbers first, 3 and 6 do not have the same base, so but it's still a multiplication problem, so we could still multiply those. So 3 times 6 gives you 18. And then we go on to the variables. So we have two x's, and we're going to add those powers together. So 3 plus 8, and then for the y's, we'll add those powers together, negative 7 plus 2. Okay, so again, 3 and 6, since they don't have the same base, we're just multiplying them together. It's still a multiplication problem. And then x, 3 plus 8 gives us 11. And y, negative 7 plus 2, gives us a negative 5. And then again, we notice that we have a negative exponent. That's not okay. We can't have that. So we make it a fraction over 1. We identify the problem with this negative exponent and then move that part only. So the 18x to the 11th will stay right where they are, and the y to the negative 5th will move down to the denominator and become a positive 5. For your final answer of 18x to the 11th all over y to the 5th. So here's the new stuff, the new exponent rule that we're learning today. Anytime we have something raised to a power and that is raised to a power, we just multiply them. So yesterday we had something like, we have something raised to the power times something raised to another power, and then these we would add the powers together. So now we have something raised to a power, and then that's raised to another power, and then those two get multiplied together. Okay, so let's, oops, this keeps disconnecting. Let's go through a couple of examples here together. So the first one, again, we're going to start off with some basic problems here. X to the third times x to the sixth, or raised, x to the third raised to the sixth power. So again, what we're doing is we're going to take those powers and multiply them. So 3 times 6 gives you 18, okay? And that is all we are doing. Now we're going to add some extra terms in here with some of these problems, and we're going to combine this, this concept with the one from yesterday. So we're going to put a couple things together. So here, this one is done for you. So again, negative 4 times 7. So that's the first thing we're starting with, is negative 4 times 7. So multiply those. Negative 4 and 7 gives you negative 28. And now we have a problem because we can't have a negative exponent. So negative 28 is the problem. Move it to the denominator, so we make this a fraction over 1. And the other thing you have to remember is that when we move that down, there is nothing else left in the numerator, but that doesn't mean that we leave it blank or we fill it in with a 0. When we move everything out of the numerator, we have to fill that in with a 1. So our final answer is going to be 1 over a to the 28th power. So that's combining the exponent raised to an exponent with the negative exponent. This one is combining the exponent raised to an exponent with our multiplying rule that we had done in the previous day's notes. So the first thing I'm going to do is I'm going to recopy this c to the 5th. All right, there's nothing happening with that one just yet. The first thing that I need to do, though, is I need to take these two, just like you're following your order of operations. Remember, these exponents are being multiplied, so we're going to multiply the exponents before we do the, the exponent rule where we add the exponents when the bases are being multiplied. So for that second part there, we're going to have, this is times c, now these need to be multiplied, so 3 times negative 2. All right, and you could probably do that in your head. You don't have to show a separate step for it. I'm just showing a separate step so everybody can see exactly what's happening here. So c to the 5th times 3 times negative 2 is negative 6. Now, I like to save my moving negative exponents around for my last step, because sometimes when we combine these two together, we get rid of a negative and then we don't have to move it. So I like to save that for my last step. Now, we don't have that here, but sometimes we do. So the next thing, when we're multiplying common bases, so these both have a c, we add the exponents. So 5 plus negative 6. Add those together, and we end up with c to the negative 1. So now, since we have a negative exponent, we have to make this a fraction over 1. We identify the problem by circling it. So here's the problem. And then move it to the other side of the fraction. So my final answer is 1 over c to the first power, which we can even simplify that further because we don't need to have that power of 1. We could just write this as 1 over c. So that is your final answer there. Next one, same thing here. We have multiple steps being done. So first of all, we are going to multiply. So 4 times 2 and 2 times 5. So we'll do those separately like you see here. So multiply those, 4 times 2 and 2 times 5. So we start off with a to the 8th and a to the 10th. And then just like in the last problem, we have similar bases being multiplied, so we add the exponents. So then we have a, adding the exponents, 8 plus 10. Add them together, 8 plus 10 gives you 18. Final answer, it's a positive exponent, so we are finished. Up next, we're going to go through this one together here. Because this one is actually very, very simple, I'm going to bring down the b squared, and then something that we should recognize, maybe you don't recognize it in this step and you have to do something first, but anything, this is going to be your anything right here, b to the 7th is your anything, raised to the 0 power is 1. But let's say we didn't recognize that and we multiplied those. 7 times 0 is 0. Still, b to the 0 is 1. So my final answer, b squared times 1 is just b squared. Okay, so that problem could actually be done very simply and quickly in a matter of basically one step. If you recognize that this right here is equal to 1, you really didn't need this middle step of b to the 0. Okay, now that is everything that I had on your notes, but I wanted to point out something that happens a lot is when you see problems like this, if you want to jot this one down at the end of your notes or something, or just pay attention to what's happening here. Now, whenever there is no exponent for a variable or a number, we always want to make sure that we fill that in with a 1. Because what happens is when we have a squared outside here, we end up with saying like this is just like a 7, so people tend to just bring the 7 down, and then they say m, and then, well, 3 times 2, this is going to get multiplied. 2 times 3 would be 6, and then x, 2 times 5 would be 10. And the problem there is this 2 also has to get multiplied by that exponent, so this should be a 1 times 2 to be 7 squared. And I believe that's something that shows up on the notes for 1 for h, but I wanted to point it out now because the more you see it, the more familiar you'll be with it. But so yeah, I just wanted to add that extra problem in there. So again, if you have any questions, go back through the notes, rewind, watch the problem again, and again, if you're not sure, just make sure that you ask me any of these questions, because we're going to keep adding on to these exponent rules. So if you're not sure about some of these exponent rules now, as we're adding on to them, you're going to get further and further behind. So just make sure you're asking questions as we go through these notes.